Welcome to CEC lectures. Myself Dr. Preeti Jagwani. I am from Department of Computer Science, Aryabhat College, University of Delhi. So as you all are aware that we are presently learning our series of database management system. Today's topic in this series is about index authorization, and we will also look at some of the data types in SQL. So let us begin with index in SQL. So when I say index, the first thing which comes in my mind or which comes in a normal man's mind is actually kind of, we can say, the last pages of a particular book in which index is being formed and page numbers are being written. Now, if I ask you a simple question that what is the utility of that index? So, for example, each and everything cannot be given in the context contents, and if you are looking for a particular word, so that word can be looked into index, and you can directly jump to the particular page which is containing the index, which is containing the term which you are looking for. So, basically the bottom line is index is index is useful when you want to speed up your search. Similar is the utility of index when we talk about here SQL, or when we talk in terms of databases. So you all are aware that many queries are going to reference only a small portion of records in a file. So for example, in a university database, I am having students records of, let's say, different colleges, and each college is having, let's say, kind of 2500 records or something of that sort, and in a university this number of records can go up to 1000, and in archives it may go up to lakhs also. And now the question which I am looking for, or the information which I am looking for, is actually the total credit value for a student with ID, let's say 22201. So the query will go like this: find the total credit value of the student with ID is having ID as with ID, where ID is equals to 22201. This is going to be the SQL query. Now, it is going to be very inefficient for the system to read each and every record in order to find this record whose ID is 22201. Now, here, in order to speed up the search, we can take the help of an index. So that index on an attribute of a relation is actually going to be a data structure which will allow the database systems to find the tuples that have a specific value for that particular attribute, and this search is going to be very efficient. So for example, I want to create an index on a particular attribute in a relation. So whenever I am going to look for that particular attribute or a specific value of that particular attribute, my index will be my search will is going to be speed up. Now, this is why this is happening, because if a particular index is there, your a system is going to search for that particular attribute using the index, and instead of scanning through all the tuples of the relation, the database system will find the tuples that have a specific value for that particular attribute. So how are we going to create the index, and what is going to be the example for this? So let us see. So in order to create an index with the create index command, so create index is the command, and after create index we are going to give the name. For example, I1, this is going to be the name of the index on which particular relation I want it. So for example, I want it on the student relation, and the attribute is, let's say, ID. So the whole query will go like this, or the whole command will go like this, that is create index I1 on a student, and within the bracket I will be writing ID. So for example, I am having a student table which I have created having ID as varchar 5, name as varchar 20, and it has been specified as not null, then department name as the varchar 20, and there are total credits which is in the form of numeric field 3, 0, whose default is 0, and here the primary key is going to be the ID. Now, in order to create a index for this particular student, we need to figure out a particular attribute on which we are going to index, because and then when we will look for values, particular values of that particular attribute, your index will be used. So, for example, I am going to create an index on the student ID. So, in order to do that, I will write the command as create index student ID index, which is the name of the index. I could given it kind of a simpler name, but this is more logical here. So, I will say create index student ID underscore index on student, which is the name of the relation, and ID is the name of the attribute. So, now if I am going to fire a query, let us say for select I can say select name where ID is equals to so and so. So, index has been already created on the basis of ID, and now I am asking for some particular information related to any of the ID which is available there. So, in this situation, the system is not going to look for the whole tuples, instead it will look for the index, because on the basis of ID we have already found we have already made an index. So, the query, let us say select a star from student where ID is equals to let us say 1 2 3 4 5 can be executed very efficiently, I can say, in terms of speed. Why? Because now the index is being used in order to find the required record, and it is not going to look for all the records of the student. Index with ID, index which is based on the ID is already being created, and now I am asking for the information of a particular ID. So, obviously the index will be used in order to look for the or in order to locate for the particular record, and on the basis of index it is going to be very efficient in terms of speed also, and this will happen without looking at all the records of the student. So, this is actually I can say the idea of your indexes. Now, coming with another we can say a very small topic here, but very important, which is about data types in SQL. Presently, if we recall our previous lectures, we can say what common data types which are already available that we have seen. We have seen character, which is char, then we have seen varchar, which is kind of a variable character, then we have seen integer, or it could be kind of numeric if we want to have let us say a real value, then we can use a bool or we can have float. Now, this is actually, these are the data types which we use commonly. There are certain, these are certainly not the exclusive list, because if we are going to, for example, looking for string data types in SQL, this itself is a long list. Then if we look for numeric data types in SQL, that also contain a lot many of data types which are already built in. But this char, varchar, int, bool, float and numeric are the data types which which are commonly used and which we have seen in our kind of we can say previous lectures. Apart from this, if we look for, so one category is kind of let us say about the data types of string related data types, then another category could be number related data types which we have already seen. Now, the third category is related to the date and time data types. So, the data types which are going to contain the information on date and times. So, that we have not seen in our previous lecture, and here I am going to give you a glimpse of what are the common data types which are used in date and time category. Again, this list which I am going to give here is not exhaustive, because the list is actually we can say long. So, the first data type in date and time category is date itself, which is, as the name indicates, it is going to we can say it is going to contain the date, and the date you can always control the format or you can always change the format, but by default it is going to be a 4-digit year, not a 2-digit, it's a 4-digit year followed by a month and then the date. So, I can say YYYY dash then the month and then the date. This is going to be the format. So for example, the date is, I can say 27th of July 2005. So it is 2005 7/27. And so if let's say I am going to say in a particular um, in a particular relation, if I need to in the student relation, if I need to record the admission date. So for admission date, we will be using the data type as DATE, which is the date, and the exact date of admission of a particular student can be contained in that. Now it is not only about the dates, we also in some of the scenarios it is very common to have time, which is the time of the day, that is going to be in hours, minutes and seconds. That is the default we can say format. This is obviously again it's subjected to the modifications we can say. So example will be, let's say 9 o'clock and 30 seconds elapsed 9 o'clock. So 9 00 30, or it can have precise time as 9:30 9:00 and then 30.75. So hours first, then the minutes and then the second. Here also you can control the format, as in you need the time in 24-hour format, or you need time in 12-hour format. That also can be modified, or we can say that also can be controlled. Apart from your date and time, one comes as timestamp. Timestamp is about date plus time of the day. So for example, we have seen in our previous lecture, we have seen the transaction. So for example, I want to note down, or I want to record the exact date and time of committing a transaction, or maybe exact date and time of roll back of a transaction. So in these type of scenarios, we need to have date as well as time, both in combination. So timestamp data here is to save us, which is the combination of the date which we have seen earlier in the form of 4-digit year, month and date, followed by the time in hours, minutes and second, and the timestamp which is going to be formed with the previous which we have previous examples which we have seen of date and time, is going to be 2005 7/27, that is 27th July 2005, and the time is, let's say 9 then 00 and then 30, or maybe 30.75, up to what precision you need it. That depends. Now apart from this, you have some special types of data types which are already built in. So here till this point we have seen the data types, or which we have used, what data types which we have used are character data types, then string data types we can say basically. More correctly, then we have seen the number data type, which is based on the numeric or integers. Also we have seen some date and time data types in the date and time category. Apart from this, we have large object types also. Now this is again going to be a huge or it's a long list of large object types which are being supported in SQL. So here we will be looking into brief of two large object data types. One is blob and another one is clob. Blob stands for binary large object and clob stands for the character large object. So let us try to understand first that what actually this large object is. So as nowadays everything is being stored in a database, or storage is a lot of requirement nowadays, and we have also seen the systems in which there is a kind of requirement of not only storing the simple text, but instead of along with the simple text, a user may wants to store the photos, which is a very common requirement nowadays. Apart from photos, it could be video files or videos, or it could be some CAD files, etc. So these all are very different from storing the text or very different from having the dates stored or having the numbers stored. So all these your photos, videos and some files are stored as objects, and these are named as kind of we can say large objects. So in this category of large object types, we have binary large object, which is we can say we recognize it with the help of the keyword blob. So here the object is a large collection of uninterpreted binary data. Apart from that, if the object or the file is in the form of character data, we can use CLOB, which is the character large object. Here the object is going to be a huge collection of the character data. So depends on your requirement or how your data is being formatted or structured. You can have the contents of that particular object which we want to store. If these contents are in the binary format, you can use blob, or if these contents are in character format, you can use CLOBs. And in various programming languages which you have seen till now, you have I'm sure that you must have interacted with files which are in the binary format and the file which are in the form of characters. So those files, if we want to store in the database, can be stored with the help of blob and CLOB. Now one very important point here is, when a query or kind of any statement or any command is going to return these type of large objects, blob, CLOB or others which are available, it's not that the whole large object is being returned. Actually it's a pointer to that particular large object which is going to be returned, rather than the whole large object itself. So that is something important, which is kind of we can say an optimization, a way of optimization from the perspective of we can say efficiency increase. So till this point we have seen character data types which are string data types, then numeric data types we have seen. We have also taken a view on the date time data types, and we have also seen a large object data type category. So these were actually we can say this was actually a snapshot of what built-in data types are available with SQL. Apart from these built-in data types, a user can also create its own data types. So a user when is going to create its own data type, that comes into the category of user defined types. Now how a user defined data type can be created, that we will see. So in order to create a user defined type or user defined data type, it is like the query is like create type, and then we can say whatever the name of new data type you want to keep, that then as the old sample data type. So for example we can say create type dollars as numeric 12, 2. Now here your dollars is going to be a data type which is similar to as of your numeric 12, 2, and you can use this dollar in place of numeric 12, 2 anywhere wherever you want to use numeric 12, 2 within this system. So for example I can use this dollars as create table department, in which the fields will be department name, that is of varchar 20, then building name or building simply we can say, which is of varchar 15, and then there is a budget which is of type dollars. So which is of type dollars means now dollars here is basically used as a user defined data type, which signifies is numeric 12, to the standard data type. So we will be using create table department, department name varchar 20, building varchar 15, and the budget which is in the form of dollars. Finally that is going to be the numeric 12, 2. So here as you have seen that we have created one user defined data type which is named as dollar, and now this dollar can be used, wherever you want to use this numeric 12 comma 2. So this is, kind of, we can say, it is not only the SQL built-in data types which are available in the repository, which are available with SQL. You can also create your own user-defined data types, and even, the domains also can be created. So till this point, what we have seen is, in this lecture we have seen, two things. One, which we have seen as data types in built-in data types in SQL, and another one we have seen the concept of index. Now with this, let us proceed with, the next topic, which is about authorization. Now before going into authorization, let me recall that in the initial lectures, when we have seen what is the difference between a normal, kind of a flat file system, I can say, and the database management system of, storing the data. So we have, one point which we discussed at that time was about authorization or about security. That means in flat file system, it is going to be we can say a system in which each and every user is being given access to each and every file, and there is no hierarchy, or we can say kind of there are no roles or no authorization built-in facilities. Now here, in case of database management system, in order to have the security concerns, in order to have the security implementations, we can use the concept of authorization, and it is not only the kind of, we can say, security constraint, but which particular staff or which particular user will be allowed to access what which data, and more specifically in which of the modes. That is going to be something very important, and all these we can say things will be controlled or will be covered under the umbrella of authorization. So let us try to kind of understand this authorization in detail. So the first is authorization is actually assigning a user various permissions, or here these permissions are basically known as privileges. So these permissions or privileges are given, or I can say even revoked, or assigned to a user on various parts of the database. So if I am talking about parts of the database, that means I am talking about your not only the relations, but apart from this relations, we are also talking about the views, we are talking about the indexes, and so on and so forth. So on these parts of database, if we actually want to control the authorization, that who is going to who is going to access what and in which manner, that whole thing is covered under the concept of authorization. So authorization is about assigning a user several forms of the authorization on various parts of the database. Now what forms of authorization I am talking about? So if you have gone through Linux, in which in Linux or in Unix system, we have permissions of read, write, execute for different files. So here also we are going to have permissions which is in the form of read. Then we have insert, we have update, and we have delete also. So read, as the name indicate, it allows reading but not the modification of the data. Then insertion allows the insertion of the new data but not the modification of the existing one. Update allows the modification but not the deletion, and delete itself allows the deletion of the data. And these type of forms of authorization, as I told you, in the language of SQL, we call them privileges. So we can authorize the user maybe a combination of these type of privileges, all of these privileges, or maybe none of these privileges on various parts of database, and these parts of database could be a relation or a view. So this is what we can say a fundamental concept of authorization is. So here in this lecture we initially started with the concept of index, and then we have seen some data types which in the category of built-in data types as well as user defined data types in SQL, and then we have understood the concept of authorization. This concept of authorization we will take further in our upcoming lectures. Hope you have enjoyed this one. Thank you for watching. I will see you in the next lecture, and here is a list of references which is being used for the preparation of lecture. Till then, goodbye, thank you, take care.